Hi. Going to look at an example of basically the volume of a cone. There's two types of questions that generally get asked here. Sand or gravel being piled up in a cone, or a cone like in a funnel that's draining liquid. Okay, they're very similar in how they're done. They're generally asked the same things. Obviously, you're going to get different results. The sand and gravel pile question, generally, those are going to increase the rates. Okay, so you're going to have positive values for the change in height, change in diameter, change in radius, change in volume, all the things that can happen to a cone. Whereas on the funnel question, since you're leaking liquid or you're losing liquid or you're draining, whatever you want to call it, everything's decreasing. So you should expect negative values for the radius, the height, diameter, volume, surface area, all of those things. So when it's piling up, positive values. When you're leaking liquid or you're draining or whatever, now you're looking at negative values for basically everything. So let's take a look at this question. So I got sand pile, okay? So sand's being dumped into a cone, basically. So it's getting dumped from a conveyor belt at a rate of 25 cubic feet a minute. And then it's forming this conical pile on the ground that we see where the diameter of the base is half the height. Okay, so that's a kind of a clue that we're going to come back to. And then how fast is the height of the pile increasing when the pile is 10 feet high? Okay, so if you've watched the other videos, I really like to list what we know and what we're trying to find. Okay, so what do we know? We know how the pile is increasing. Okay, so we know a change in volume with respect to time. So that volume is increasing at 25 cubic feet a minute. What else do we know? Oh, we know the diameter of the base. Okay, so this guy is half the height. Okay, so whatever the height is, I cut it in half. I now know my diameter. Okay. Anything else? Nothing really there, okay? And so now what are we supposed to find? So we're supposed to find the change in height with respect to time. So derivative height with respect to time there. When the pile is 10 feet higher, when height is 10 feet. So I've listed what we know, what we need to find. I have a nice picture here, hopefully help me visualize what's happening. And now you need to know a piece of information here. We need to understand, obviously, we're going to deal with the volume of a cone. So the volume of a cone formula is 1/3 pi r squared h. Okay, you should know that. Very likely, certain volume formulas are given to you on an AP exam. They just don't really expect you to remember all your geometry, even though you should. So we're going to take the derivative of this, but you kind of should be freaked out right here because, hey, I never talked about radius, okay, at all. So I got to start thinking about what's going to happen if I take the derivative and I got this r guy in here, okay? What you should hopefully notice by now is that on all these related rate questions, if they're giving you something for each rate, okay? So they're either giving it to you saying, hey, this is what you know, or this is what you should find. There's never a moment really where they're going to make you like figure out two different rates, okay? So the fact that I don't know what dr over dt is, it's not told to me, and I'm not trying to calculate it, that's a big red flag right away, like, uh-oh, something's going on here. And so that's going to come to this little line right here that we need to pay attention to. There's a relationship that's going to stay constant between my diameter and my height. And so what I'm going to do is I'm going to basically get rid of this radius by talking about radius in terms of height. So I know that if I double my radius, I get a diameter. So I'm going to replace the d with 2 times my radius, and I'm going to leave that the same. Now, I want to know what the radius is in relationship with the height, so I'm going to divide both sides by 2. And when I do that, I'm going to get my radius is the same as 1/4 of my height. And that stays no matter what, okay? As that pile grows, the radius is always 1/4 of the height. So instead of writing down r, I'm going to write down 1/4 h. Now I have an equation where once I take the derivative, I have dv over dt taken care of, and I'm trying to find dh over dt, and there's no other variable that I have to fool with, and this is what we want. So obviously a nice little cleanup step would be good here, because we really don't want to do anything right now. So let's clean it up. So the 1/3 stay in there, the pi stay in there. Let's square the inside here, so that's going to turn into 1/16 h squared times h. And so my next step is going to be, okay, well, 1/16 times 1/3, that's 1/48 pi, and then h squared times h is h cubed. Now we're ready to take the derivative, okay? I think once you get to the calculus, it's actually an easy question. It's the setup on these related rate questions that are the challenge. So I'm going to take the derivative here. So the derivative of volume with respect to time, so the change in volume over time is going to be 3/48. That's the same as 1/16 pi h squared dh over dt. Now at this moment you should be able to just plug in, okay? And that's after you take the derivative, that's really the intent every time. So what do I know? I know that this is 25 cubic feet a minute, so I know that. I know that the height in the instance where I'm interested in the change in height is going to be 10. And so there's that dh over dt at the end. That's the only unknown, and that's the good point, okay? So I got 25 equaling 100 over 16. That's what? 25/4. So I got 25 pi over 4 times dh over dt. And obviously we're going to divide, or I like to multiply both sides by the reciprocal. Okay. And in doing so, okay, you can see the reduction happen. So I got dh over dt. Oops, sorry folks. So once again, from this step, multiply by that reciprocal, or you could divide if you're a calculator freak. I personally would rather do this, and so I'm going to get 4 over pi. So I guess my answer is 4 over pi feet per minute. Okay. Hopefully this is helpful. You should find similar questions throughout your assignment. You're going to see one very similar to this on your quiz. A little bit of a challenge because we have to make that substitution here. But once you make that substitution, life should be good, okay? Let me know if you need any help.